In this video, we will look at factoring polynomials by grouping. To factor by grouping, there are a few steps that must be followed. I have the 5 steps listed here. For the first step is you must have 4 variable terms that should be added or subtracted together. The next step is to group your terms together 2 by 2. The following step is in the first group, find the greatest common factor and factor it out. The next step would be to, in the second group, find the greatest common factor again and factor it out. And then lastly, you're to look at what you have factored and then factor what's left completely. Let's look at the box to work them out. If you consider xy plus 2x plus 3y plus 6, our first group is xy plus 2x. Our second group would be 3y plus 6. Now our next step is to factor the greatest common factor out of group 1. From group 1, they both have a common x variable, so we'll factor out an x. And we'll write what's left. Once you factor out an x, it's like you're dividing each variable term set by x. So doing that, it leaves us with y plus 2. From group 2, we'll look for the greatest common factor again, and between 3 and 6, our greatest common factor is 3. So we'll factor out a 3. What's left again is like you're dividing each term by 3. That 3 you factored out, so we're left with y plus 2. Now what we'll do is rewrite our problem with the 2 groups. Remember, we were adding. So our first group looks like this. And add it to our second group. Now looking at the 2 groups, our last step is to continue to factor completely, and this is the tricky part. You have to notice that of the 2 groups, this term and this term are alike. So we can factor out this like term of y plus 2 and write what's remaining, which is our x plus 3. Alright, now let's look at another example. In example 3a, we're given 8y squared minus 2y plus 10y minus 15. So again, just like before, we'll create our 2 groups. That would be considered our first group, that 8y squared minus 12y, and our second group would be our 10y minus 15. Now from the first group, we have to consider the coefficients and the variables to find the greatest common factor. Of the coefficients, 8 and 12, our greatest common factor is 4. Of the variable terms, remember that you're supposed to take the like base variable with the smallest exponent, that would be y. So our greatest common factor for this set is 4y. Once we factor that out, we're left with 2y minus 3. From our group 2, or our second set, our greatest common factor we're considering between 10 and 15, the coefficients and constants. Our greatest common factor is 5, and it is a positive 5, which leaves us with 2y minus 3. Now, just like before, if we look at our entire set and continue to factor completely, we notice that this factor and this factor are alike. So now, our completely factored form of this problem becomes factoring out the like factor 2y minus 3, and the factors that are remaining are 4y plus 5.